Today, we mainly focus on the mole concept. So, what is mole concept? Mole is a number. Let's see the concept related to mole. The first one is molecular mass. We normally relate molecular mass with the mass of carbon-12 as a comparison. We assume that carbon-12 equals to 12.00000, and all other elements or compounds will be compared with carbon-12. We assume that the mass of carbon-12 is exactly 12.00000. But what does that 0.00000 mean? It means the number is of high accuracy. It is accurate to this decimal place. Theoretically, carbon-12 can be compared with all other elements or compounds, so there is no unit for carbon-12. There is no unit is because carbon-12 is just a comparative number. Molecular mass is the sum of atomic masses of all atoms present in a molecule. Since we know that not everything is a molecule, there is another term called formula mass. The formula mass reflects the mass of substances in the chemical formula compared with carbon-12. How should we do the calculations? It's quite simple. We just need to add up the atomic masses of all atoms present in the chemical formula, and this is called formula mass. There is no unit for formula mass, as it is just a comparative number with carbon-12. Let's see another term, which is called relative isotopic mass. It is the mass of an atom of the isotope as compared with an atom of carbon-12. Since it is a comparative number, it does not contain a unit. Relative atomic mass is made reference to carbon-12 as well. It represents a number when carbon-12 is equal to 12.00. It is the weighted average of the isotopic masses of all the isotopes. To be repeated, both terms do not contain a unit. Then, we're going to see what mole is. Mole is the amount of substance. What is mole compared to? It is also compared to carbon-12, which means the number of particles present when the same number of particles of carbon-12 weighs 12 grams. In general, 1 mole is equal to 6.02 times 10 to the power of 23, and it is known as Avogadro constant. Avogadro constant is a constant number, and 1 mole is equal to that specific number. How can we understand this huge number? In fact, if you have this huge amount of money, you can never count it, as it is a very big number. We can represent mole as a number, just like our usual term, a dozen, which is equal to 12. So, if we need to calculate the amount of a substance in mole, we can just divide the number of formula units by Avogadro constant. Another definition is molar mass. Molar mass is the mass in grams of 1 mole of the substance. If we would like to convert mass into mole, we need to divide the mass of the substance by its molar mass. Once again, you can treat mole as a number, a huge number. Next, we will see what information can be provided in a chemical equation. A chemical equation is a symbolic representation revealing the quantitative relationship. What is a quantitative relationship? It is the relationship of the reactants and the products in a reaction. So, first, we usually have to look at its stoichiometric ratio. And second, we usually use a chemical formula to represent a substance. The other thing to do is to balance the number of atoms of both reactants and products. Sometimes, you also need to write down their physical states. Here is a simple example. This example shows the water produced from hydrogen and oxygen. What information can this equation provide us? First, we can know the ratio of the substances, which is the ratio of hydrogen to oxygen, is 2 to 1. From the formula, we know that 2 moles of liquid water is produced when 2 moles of gaseous hydrogen react with 1 mole of gaseous oxygen. It gives us a clear idea of the ratio of different substances in this equation. Second, we can also know their physical states. For example, gaseous state and liquid state in this case. And the number of atoms in the equation are all balanced. Take hydrogen as an example. 2 times 2 equals 4, and so therefore H. Here again, 2 times 2 equals 4. All the atoms in the equation are balanced, so the equation must be balanced. We're going to do some calculations using mole. In example 1, there are 0.02 mole of hydrogen and 0.01 mole of oxygen. First, we have to write the chemical equation. But this example has given you the equation already. Now, we need to calculate the number of moles of water produced. We can see the ratio here is 2 to 1, and the ratio of 0.02 and 0.01 is exactly 2 to 1. All reactants will be used up. If 2 moles of water are produced when there are 2 moles of hydrogen and 1 mole of oxygen, 0.02 mole of water will be produced when there are 0.02 mole of hydrogen and 0.01 mole of oxygen. We can know the ratio of hydrogen and oxygen from the chemical equation. Next, we make use of the ratio in the equation. Since 2 moles of water is produced when there are 2 moles of hydrogen and 1 mole of oxygen, 0.02 mole of water is produced when there are 0.02 mole of hydrogen and 0.01 mole of oxygen. It is just a proportional number. We're going to see another example. 0.4 grams of gaseous hydrogen reacts with 3.2 grams of gaseous oxygen, and the chemical equation is the same as example 1. We need to calculate the mass of water produced. In general, the first step of calculations is to convert all units into mole if the question does not give you any number in the unit of mole. This is the simplest approach. So, we need to convert 0.4 grams of hydrogen and 3.2 grams of oxygen into the respective number of moles of hydrogen and oxygen. Then, we also need to check if the ratio in the chemical equation is correct. We need to calculate the number of moles of hydrogen by dividing the mass of hydrogen by its molar mass. For hydrogen molecules, its molar mass is 2 times 1 equals to 0.2 mole. Similarly, we need to calculate the number of moles of oxygen by dividing the mass of oxygen by its molar mass, and we will get 0.1 mole. As you can see, 2 mole, 1 mole, and 2 mole here. So, 0.2 mole and 0.1 mole of reactants can be totally used up. As all reactants are used up, 0.2 moles of water is produced. Since we need to calculate the mass of water instead of number of moles, we're going to convert moles into mass. We just need to multiply the number of moles of water with its molar mass. The molar mass of water is 18. The final answer is 3.6 grams. In this simple example, the first thing you need to do is to convert mass into mole. Next, check the ratio in the chemical equation. All reactants are used up in this example, so we can use the same ratio to calculate the number of moles of water produced. Then, convert the mole into mass, which is multiplied by 18. This is a simple way for calculations.